Hello everyone, my name is Beatriz Castillo-Téllez. I'm from Mexico and I work in the Universidad de Guadalajara in Guadalajara, Jalisco. I'm presenting my work or our work that is named Edamame, drying, modeling kinetics and properties depending on solar technique. Edamame is the immature soybean and is harvested when it reaches 80% of its maturity. It has many benefits. It's rich in protein, phosphorus, calcium, iron, vitamins, and fiber. It has a high potential to prevent cancer and decreases cardiovascular risk. Edamame contains a lot of water. This humidity facilitates the reproduction of many organisms inside the food, and because of this, a percentage greater than 20% of the total cereal harvested is wasted around the world. On the other side, 205 million people live with food insecurity, and by 2019, 135 million people suffer from severe hunger around the world, and the ONU predict that because of the COVID pandemic, this number could be doubled by the end of the last year. To prevent edamame waste, there is some technologies that are used to conservation of edamame as freezing by hydrofluidization, freezing drying, vacuum microwave, or vacuum infrared. Because of the techniques that are using around the world by now are very complex, we are proposing to use solar drying. Solar drying maintains the food hygiene. It has a fast drying times. You use sustainable energy, and anyone can do this even in our own house. We use the immature soybeans that were selected, and the weight of the samples at the beginning of the experiment was 20 grams. During the experiment, we measure the humidity in the chambers and inside the food. We measure water activity, temperatures, weight, and we perform an analysis colorimetric study for both technologies. We use two technologies. One of these are a direct solar dryer with a chamber with transparent polycarbonate cover, and also we use a mixed solar dryer that use a solar air collector to provide the heat inside the chamber. These are our results and conclusions. In this slide, you can see that the mixed solar dryer could reach a higher temperature and low relative humidity than the direct solar dryer. In this graph, you can see the equilibrium moisture content, and mixed solar dryer needed about 350 minutes, and direct solar dryer needed a longer time as 500 minutes. In this graph, we present the drying rate from the both technologies, and as we can observe, the slope were about the same, but the mixed solar drying present a more homogeneous drying rate. These are the models that we use to feed our experimental results. This modeling is important because then you can save time with experimental, and also you can design dryers too. However, the model that we best fit our experimental results are the weighable for both technologies. Here you can see the colorimetric analysis for both technologies. And as you can see in the table and in the graph, the color has a good preservation in both technologies. These are our conclusions then, and the kinetics and colorimetry were analyzed during the drying. The results show that the mixed solar dryer is the technology with the best results for the edamame drying because it presents shorter drying time, and it presents to a less total color change. About the modeling, the Weibull model was the better matched to the experimental results of edamame drying. Thank you very much for your attention.